Hello, I'm Dean Whiting from Pathology Technology Australia. The pathology technology suppliers are working at incredibly high capacity at the moment to maximise the testing available to fight this COVID-19 pandemic. Manufacturers are working 24/7 to maximise production and make sure that they get to all of the testing centres around the world. Scientists in R&D and in manufacturing are constantly looking at how they can improve and optimize these products. A very good example is the PCA, the polymerase chain reaction that we use to detect the viral DNA. You've heard me talk about this in the past. So this is where the detection of the viral DNA occurs, which gives us a really good idea of how much virus is present in the nose or in the lungs. So this is quite a definitive test for COVID-19. So currently we're optimizing detection of the genes on the COVID virus related to the human-to-human transfer of this disease. So it's a very important operation to make sure that we're maximizing the detection rate. We're also optimizing the ability to measure virus on sputum samples. Currently, we collect the samples through the nose. And that allows us to detect virus in the back of the throat. But it's also important to measure virus coming from the chest, the lower lungs. So to be able to optimize the measurement of virus in sputum is very important. There are also some other very important innovations coming along. Innovations around digital PCR, around something called microdroplet, which is going to improve the lower level of detection and the reliability of detection for viral particles. The other important innovation that we can report on today is the availability of a 45-minute PCR-based test, which can be done almost anywhere where we find healthcare professionals who can operate the device. So in rural, remote, in Aboriginal services, they can have access to a very good PCR-based test. You've also heard me talk about antibody-based tests, the so-called serology tests. These are the tests which tell what sort of immunity you have to a viral challenge. You might have heard recently about the 15-minute blood test. And I wanted to explain a little bit about that test and how it works, and maybe to set the expectation about what this test can deliver. So the test comes in a format very similar to what you would have seen of the pregnancy test formats in a pharmacy. So you have a plastic cassette, you have a place where you pop a sample. In this case, the 15-minute COVID antibody test requires a finger stick of blood, so you've a little bit of blood coming from a hole in your finger, applied to the cassette along with a drop of a buffer. And then the cassette has inside it a paper wick, along which the sample can run. Embedded in that paper are some reagents, some chemicals, which can detect the antibodies to the virus. So after 15 minutes, with a positive sample, a line will develop on the paper. You'll be able to see that line, and that's an expectation of a positive. So you need to understand a little bit about the limitations of these sorts of tests. Antibodies can take between 6 and 12 days to develop against any viral infection. So you can imagine somebody presenting in early phase COVID infection. An antibody test may not actually detect the presence of antibodies because the body will not have had time to develop antibodies to the virus. What that may mean is that if a symptomatic person tests negative, it doesn't mean they don't have coronavirus. What it likely means is that they'll need to come back several times over the next days, maybe six or so days, to be repeat tested to see if they've gone positive. So the problem, I guess, with the application here of this kind of technology is that there's the chance of a reasonably high number of false negative results. Where the test is potentially very useful is where in a person presenting for the first time who has had the symptoms of cold and flu and who tests positive, then it's highly likely that they will have antibodies to flu. Whether it's coronavirus or not is not necessarily the case, but what that means is this person would almost certainly then go into isolation. They would have a sample then taken from their nose or their sputum to go to the lab for a confirmatory test. So the technology there is very applicable, but it has to be used in the right way. Of course, there's a different kind of antibody tests, the kind that are done in the laboratory. So the technology there is high quality antibody tests done on high volume analyzers in very highly qualified, well-run laboratories. And here there is a very, very good reason for wanting to do antibody tests. And that is to test the immunity of the population or of people who have had an infection. So a couple of applications here. This will be incredibly useful as we study the epidemiology of the COVID pandemic. That means that we'll be able to study how immunity developed in the community and where it developed and how long it took in general terms. This will also help us when we're studying the effect of, say, the vaccinations. It's also useful for individuals who have recovered from coronavirus to determine their immune status. Are they immune? So I hope that's been helpful. There's some improvements in what we're doing. Both we're ramping up production, we're improving the technology. The technology is there to detect the virus and also to detect antibodies. But we need to use the right technology in the right place at the right time. I'm Dean Whiting from Pathology Technology Australia.